Assalamualaikum and greetings everyone. In this video, our group members, that is me, Amirul Afiq, Hakimi Syed and Muhammad Shafi'i will talk about the pollution caused by the particulate matters. Later in this video, our group members will explain about the categories of particulate matters, health and environmental impacts, some policy snapshots, the technology we use to battle this pollution, and the future roadmap on how to reduce it. Starting first, I'll introduce about what is a particulate matter. Particulate matter is a mixture of very tiny solid and liquid particles suspended in the air, which can then be inhaled into our lungs. These particles originate either directly from natural sources or human activities. There are currently two categories, that is primary and secondary particulate matter, based on how they are formed.
Hi, my name is Hakimi Syed and for my part, I will be explaining about primary particulate matter. Primary particulate matter refers to particles that are directly emitted into the air in solid or liquid form. Unlike secondary particulate matter, these particles do not form through atmospheric chemical reaction. They are released as particles and remain in particulate form after emission. Primary particulate matter is commonly classified based on size. PM10 consists of larger particles such as dust and pollen. Meanwhile, PM2.5 include finer particles like soot and smoke, which they are smaller and more easily inhaled. Natural sources of primary particulate matter are dust storm, wildfire, volcanic eruption, and sea spray. Although these sources are less controllable, they are still contribute significantly to particulate pollution.
About secondary particulate matters, it is not emitted directly from its sources, as it is produced from chemical reactions which involve gases in the atmosphere. The size of the particles are mostly very fine, or known as PM2.5. Due to its tiny sizes, the particles can travel very far from its origin and be suspended in the air for a long period of time. Secondary particulate matters plays a significant role in most environmental air pollution cases.
Now that primary and secondary particulate matter have been explained, I will be discuss about their health and environmental impact. From a health perspective, fine particles such as PM2.5 are very harmful because they can penetrate deep into the lung. The exposure to these particles will increase the risk of respiratory disease such as asthma and bronchitis. Children, elderly, and individuals with pre-existing conditions will facing a higher risk because long-term exposure can make their condition worse. Environmentally, particulate matter can disrupt photosynthesis by settling on plant surface and blocking sunlight. It also reduces air quality and visibility, which contribute to haze. In addition, particulate matter damage building and cultural monuments, and it may contribute to climate effects, especially particles like black carbon.
Hello everyone, my name is Muhammad Shafi'i bin Azmi. Today, I will present our critical analysis of mitigation strategies for a particulate matter and our final recommendation. To effectively stop a pollution at the source, we examine the technology battle between two major industrial solutions, electrostatic precipitator or ESP and a fabric filter, often called a baghouses. Our research highlight a clear trade-off. Industries generally prefer ESP because they are cost-effective and allow air to flow easily. However, they struggle to capture certain of the high resistivity dust. In contrast, baghouses are the superior choice for the public health. They can capture over 99.9% of the fine particles, including dangerous PM 2.5. The downside is that they require more energy to operate, which increase costs. The verdict is clear. While ESP save more money for operators, baghouses save lung for the community. In high-risk zone, the performance of the baghouses is essential. Policy snapshot. However, technology is ineffective without strong policy. We compare two major frameworks. Number one is the US Clean Air Act, and number two is India's National Clean Air Program. The difference in approach is striking. The United States recently tightened its standard in 2024, lowering the allowable pollution limit from 12 to 9 microgram based strictly on health data. This action is projected to save 1,000 of lives. Conversely, India's program is facing a significant challenges. Our analysis found that the funds are often misallocated toward passive measures such as sweeping road dust rather than fixing the industrial combustion sources, which we just discussed. This demonstrates that setting target is insufficient without focused strategic spending. In conclusion, our case study revealed two key findings. First, the engineering technology is mature and ready. The primary barrier to adoption is simply the operational cost. Second, regulatory policies fail when they do not target the root cause. Cleaning the air requires strict enforcement on factories, not just cosmetic changes to city infrastructure. Roadmap. Based on this finding, we propose three specific recommendations for the future. The first one is a go hybrid. Industries should adopt compact system. This combine the efficiency of the filter with the low energy cost of a precipitator. The second one is a redefine danger. We must shift from regulating pollution by weight to regulating by toxicity. Carbon soot is far more dangerous than the mineral dust, and our law should reflect this chemical reality. The third one is a research the tropic. Finally, we need a better local data. Most current models are based on the cold climates. We urgently need a research on how particulate matter behave in hot, humid tropical weather to create an effective local solution. Thank you for your attention. That's all from us. Thank you.